We will now define our physical joins on the RPD. Physical joins define the relationship between the physical objects and the RPD. Physical joins should always be between aliases, as this separates the relationship from the physical structure. So here we can see that we have created our aliases. We select our aliases holding down Shift, and then we right-click on the tables and we select Physical Diagram, Selected Objects Only. Here we can see a physical diagram of the 4 selected tables. If we zoom out, we can arrange them in a format more similar to a star schema dimensional model. To create physical joins between our aliases, we select the New Join button here. Then we select the table that we want to join. The first table that you select should be the table with the foreign key. For example, in fact sample revenue, we have a foreign key for a customer stored inside the fact. So we select the fact with the foreign key first. You can see here, if I scroll through the columns for sample revenue fact, we have a column customer key. This is the foreign key of the sample customer's dimension customer key. So we know that we should select this table first and then this table, joining revenue to customer. So we select New Join and then this table first, followed by customers. Here you can see that our join condition is joining the customer key from customer's dimension equals to the customer key from fact sample revenue. Here you can see this as an expression. Customer key from sample customers equals fact sample revenue customer key. Cardinality being from 1 to many. 1 to many. We can select OK, and this join has now been created. We repeat this new join from the foreign key to the primary key. We know already that the office key is stored in the revenue fact. So we click the foreign key first and then the primary key. Here you can see the join is based on the office key equaling the office key from the revenue fact, 1 to many. And we repeat this finally for our last table from the foreign key to the primary key. From product dimension to the revenue fact, we join based on the product key. We can look here to see that product key is what it's joining on, and it's 1 to many. 1 to many. One product to many facts, revenue facts. We can now save, and we have finished creating the joins. We can close this, and the next step will be business model and mapping layer. The business model and mapping layer holds a logical abstraction of the physical sources. One logical table may come from multiple physical tables, and one logical column may come from multiple physical columns. It's usually referred to as the logical layer. As a developer, this is where we spend the majority of our time, as it is where most of the configuration is performed. So now that we are going to create a business model mapping layer, and I would like to explain some core concepts of the BMM layer. To begin with, at the topmost level, we have the business model, which is like a folder which contains everything below it. We have logical tables, and underneath a logical table we can have a logical table source. Now, a logical table source maps to a physical source. So we can see here that this, for example, this logical table source, which is composed from this logical table, maps to this physical table and the physical source. You can see that there are multiple logical table sources. What this denotes is that for one logical table, it can be created from multiple physical tables. So for a table, you could select data from table 1, table 2, and table 3 and include all of that data in one logical table. And this also goes for logical columns. So within a logical table, you have a logical column, and each logical column has a logical column source. And this logical column source can be composed from multiple logical physical columns. So with this explained, we can begin. Best practice is not to drag and drop our business model from the physical model, but to manually create it ourselves. So to do this, we right-click the empty space in the BMM layer. We select New Business Model. We give it a name. I'm going to name it Training. For now, we can leave it as disabled. We click OK. Now we select the following tables from the physical layer. Remember that we deal with the aliases, not the physical tables. So I'm going to select Sample Customers Dimension, drag this across. I'm going to select Products. I drag this across. I'm going to select Revenue. I drag this across. These are 3 logical tables. If we expand one of them, we can see we have a folder called Sources. So this is our logical table. We expand Sources, we can see here that for this logical table, we have this logical table source. If I double click this, I look inside it, I can see that it's mapping to this table. BI sample in the BI sample schema, dim sample customers D. You can see this is the column mapping as well. You can see that the key is defined automatically. If you select these 3 tables in the BMM layer, right click and select Physical Diagram, Selected Objects Only, you can see that the join for the BMM layer has already been defined for us. Finally, we can select the office's dimension and drag this across. If we now select all tables again and click Physical Diagram, Selected Objects Only, we can see that the joins are created for us automatically. This is because the admin tool knows that there is an underlying physical join between the new tables brought in and the existing tables. Now, within the BMM layer, one thing that we commonly do is we rename tables and give them more user-friendly names so that non-technical people can understand them. So we can do this now, simply by right-clicking and then renaming. If we look within our table, we can see that there are some columns which might not be very useful for our end users, such as the address key, the customer key. And what we can do in the BMM layer, we can delete things like this. So what we're going to do is we're going to delete the address key, the segment key, the status key, and the type key. And we can simply do this by selecting it and then pressing delete. We will repeat this for our other tables. For offices, we will delete For products, we will delete the brand key, the line of business key, and the type key. For fact, we will delete the following. We can also rename our logical columns so that they are more descriptive and our non-technical users can understand what is stored inside these columns. And we can also rename our logical columns to give them more descriptive names. So as you can see, I've renamed these columns so they make a lot more sense to our end users if they read that while they're using the BI tool. So we can repeat this process for the rest of our tables. One thing we have to be aware of with the logical columns, specifically measures, remembering that measures are stored in our facts. Measures are numeric data. The OBIEE server needs to know what the aggregation rule is for each of these specific measures. So we define the aggregation rule for each logical column. These can be things such as sum, count, or count distinct. Under the fact revenue, I will double click on the following logical columns and set the aggregation rule to sum. For fixed cost, we will start here. We click the aggregation tab. We see default aggregation rule is currently set to none. We select sum and then OK. Here you can see that the icon has changed. This denotes that this column is now a measure. For our discount rate, we set the aggregation rule to average. We can now save the model. You can see here that we have an error. This doesn't matter yet because we haven't created the corresponding physical presentation layer. What we will do now is we will create dimensions in our BMM layer. You can see here in our diagram of a dimension. We start with a grand total level and we can drill down through the data, revenue by category, revenue by subcategory. We call this the detail level. At the total revenue level, we call this the grand total level. The first step to creating a dimension is right-clicking our logical table. We will start with dim customers. Then we will select Create Logical Dimension, Dimension with Level-Based Hierarchy. We will then rename this new dimension to Customers. We will double-click the top-level dim Customers total. See that the grand total level checkbox is ticked. This indicates that this is the top level in this hierarchy and means that the level does not require a level key. We will rename this to Customers Total. We can see below this we have Customers Detail. We will rename this to Customers Detail. We will now remove the following columns from the detail level. This leaves us with customer key and name. Double-click the customer detail level and navigate to keys. We will now create a new key called name on the name column. We will check Use for Display, and we will uncheck the auto-generated key over Customer Key. This is the auto-generated key. We do not want to use this for display. We click OK. Each level in the hierarchy, except the grand total level, must have a level key which defines the unique elements at that level. The logical key for the dimension table must be associated with the lowest level of the dimension and must be the level key for that level. Each level should have one key that is used to display that level when the user drills down in an analysis. To define the key used for this, the Use for Display checkbox on that key should be checked. We will now create another dimension on Offices.